This is 1989 BC2. Alright, so the first thing we want to do is we want to write the equation, which is x squared over x squared plus 1, and it's bounded by x plus 1 and the x-axis. So now we're just going to draw the graph, and we want to pick a couple points. So I know that at 0, x equals 0, it's 0, and at x equals 1, we have 1/2. So we're just going to plug in those points and those points. Alright, and we drew the x equals 1 line, and we know that this is the x-axis and this is the y-axis. We want to find the area right here in this region. So now we want to solve part A, which says to find the area of R, which is a shaded region. So first we're going to take the integral from 1 to 0 of x squared over x squared plus 1 dx. Okay, so now we're going to solve this, but to solve this we need to do a long division, and so we take the bottom into the top, and that will be -1. Okay, so now we see that we're going to do the integral of this, and that'll be 1 minus, I'm going to just erase this so that it gets out of the way. It'll be 1 minus x squared plus 1 dx. So now what we want to do is we know that this equation right here is the same as the arctangent. Arctangent x. Alright. So now we're going to solve it. Solve it. Take the integral of it. So that'll be x minus arctangent x from 1 to 0. And now we're going to solve it. So 1 minus the arctangent of 1 minus, well, altogether, minus 0 minus arctangent 0. And then whenever we solve that, I'll get out my handy dandy calculator, we see that the arctangent of 1 is 0.78 something, and that is the same as pi over 4, so it'll be 1 minus pi over 4 minus 0 minus, and just to check that the arctangent of 0 is 0, and it is, so it'll be minus 0, so the solution will be 1 minus pi over 4 for part A. So now we're going to solve part B, which states find the volume of the solid generated when R is rotated about the y-axis. Okay, so we know that that is the axis we want to go around. And if we're going to do the shell method, you take a slice and you rotate that slice around that, and that would be x. So the equation for the shell method is 2 pi integral of 2 pi RH dx, depending on which one we're rotating around, but for this time we're doing dx. So 2 pi, and then usually I put the integral there, so 2 pi, the integral from 1 to 0 of x times, and we'll do x squared over x squared plus 1, because that's our curve. Just fix that up so you can see it better. Dx. So now we're going to solve this. 2 pi from 1 to 0 x minus x over x squared plus 1 dx. 2 pi x squared over 2 minus 1/2 the ln of x squared plus 1, and we need to make that smaller, from 1 to 0. So that will be pi times 1 ln of 2 for your answer.